The introduction of the Cummins Command series of engines brings road transport into a new age. These engines are new, powerful and different. They have improved environmental cleanliness and are designed to take transport through the 90s. You are a driver of a Cummins Command engine. The feel of the new engine could be very different to what you're used to. We're going to give you a no-bullshit explanation of the differences of Command engines and some of the driving technique changes that are necessary to get the very best in performance and fuel economy. Cummins engine specialist Terry Green will introduce you to the technical aspects of the new engines, and driver journalist Bruce Honeywell will put the theory into practice on the road. Cummins Command engine range is entirely new in concept and performance. All select engines are computer managed. The computer has well and truly entered transport. You, as a driver, have entered the computer age. Electronics are nothing to be afraid of. The computer is only a tool that will allow you to do your job better. But it is a very complex tool. The Cummins Select system allows control over the moving parts of the engine in a way never before possible. This in turn allows more power per litre of fuel, better performance, better economy, and cleaner burning engines. The computer-driven engine relies heavily on its total management of the fuel injection system to deliver more power, more economically than possible ever before. The Command engine will feel different to you. With a Select engine, you may occasionally feel that not enough fuel is getting to the engine. You put the boot in and nothing seems to happen. You could be used to older engines, where if the throttle is depressed quickly, there is a bellow, a great cloud of smoke, and the engine feels as though it's pulling. With the Command engine, this response is there, but it's not as obvious. The Select computer feeds just enough fuel to do the job. There is no overfueling. The feel is different, but the engine is doing the job cleanly and efficiently. The most revolutionary change in the Command engine is the position of the horsepower peak. The most powerful spot on the RPM band is not the highest RPM. The new Command power band brings it back to the more fuel-efficient 1600 to 1700 RPM, depending on the engine. Driving past this point brings a reduction in power. What does this mean? It means that to get maximum power, the engine has to be run at a lower RPM, and that is where there is more economy. And that is what we call the Command point. Power, performance and economy coming together at 1 RPM. This means a different feel to the truck. It means that acceleration and grunt will feel different to you.
We're telling you this engine is different. Okay, what are the differences?
Yes, there are some switches and warning lights that you may not have seen before. And the throttle pedal is connected to the engine by electric wire rather than a mechanical connection. This is truly driving by wire. Start the truck. Let the engine crank. This engine will crank longer and take longer to start than a conventional diesel engine. It does no good whatsoever to touch the throttle because the computer will not allow fuel to the engine anyway until it's ready to accept it. This is particularly so with an air start. Hold your hand on the ignition after the first blow. It's only when the revs come down that the Select engine will fire. As I said, it could take anything up to 5 seconds before the engine will fire. While the truck is stationary, the Select computer will not allow the engine to rev above 1500 RPM.
Lifting off, it's not necessary to touch the throttle, as the computer matches the load with sufficient fuel.
The difference between Cummins Command engines and other diesel engines is in the Cummins Command power band. Here, fuel economy sweet spot and maximum power and torque range all are in the low RPMs. Come on, I'll show you what we mean. On a conventional engine, such as the 444, power rises to maximum here at 2100 RPM, while peak torque is back down here at 1500 RPM. In the Command engine, maximum power is achieved well below 2100 RPM. Beyond this maximum power point, power diminishes. So for you to get the best out of the engine, you really need to drive around 16 to 1700 RPM. It just feels so much stronger there.
Okay, let's see if we can work out what Terry was saying. We're cruising in good highway conditions. The country's slightly undulating. The engine in this truck is a Cummins Command 410. Now I've let the engine run back to 1100 revs. I've put in the boot to full throttle. Just listen. As we go up through the revs, good acceleration through 1500 and the truck is really flying through 1600 RPM. This is the peak of the power band. Now we've settled at the governed road speed of 100 clicks. On the flat we felt very strong acceleration in top gear between 80 and 100 kilometres an hour because this truck is spec'd to have the power hump in top gear at around 100 k's. Now we're running this hill. Just watch the revs. As we start the pull, the RPM start to drop off in the way we're used to. Now feel the power match the hill as the power peak hooks in. It's a real power hook and stops the drop in revs. If you can hold a gear over a hill without changing gears, do so. But if you have to change a gear, go between 15 and 1400 RPM. This will ensure a smooth downshift.
The big difference with the Command engine is sound. Don't be tricked. Look out the window. Check the speedo. At 100 clicks, the Command engine is very quiet.
And more importantly, you're travelling more economically, and that means more profitably.
In speccing a truck, an operator has a wide choice of variables through which he selects a spec suited to his own operation. These specs have a large influence on the truck's performance and economy. The main variables in speccing a truck are the RPM range of the engine, the ratios of the transmission, and the diffs. There are other variables we can control, such as tyre type and size, aerodynamic efficiency of the truck and trailer, and so forth. But the main speccing decisions are made around engine speeds, gearbox, and diffs.
With the Command engine, the rule of thumb is gear fast, run slow for best fuel economy. The combination of power, RPM at governed road speed, rear axle ratios, transmissions, all decide what kind of a truck you'll have to drive. The Command engines are different and supply power at RPMs that are lower than most drivers are used to. Owners will spec trucks into three broad categories depending on the application. An economy spec would have the Cummins Command engine running at 1500 RPM or even lower at governed road speed in top gear, and that's often overdrive. To make this spec drivable, the second gear to top, often direct, has been described as a power gear. This will allow powerful assaults on hills, but will not allow governed road speed. It will be necessary to get into top gear or economy gear to achieve 100 k's, or whatever your governed road speed may be. This type of truck would be used in fleet line haul where maximum fuel economy is of highest priority. A performance spec would have the Command engine running around 1600 RPM at governed road speed. This would allow access to more power in top gear. This allows higher average speeds and less gear shifting in the hills, but there is a cost, and it will be, in fuel economy. It is spec'd where trip times and fuel economy have a priority in such applications like express or fast freight operations. There is another spec for special duty applications. Here, the Command power band would have governed road speed at around 1700 RPM plus. A high performance spec for those applications like B-doubles, road trains, high GCMs, on-off highway usage, heavy haulers like loggers and low loader operations, where road speed and RPM are continuously changing. Economy, performance, special duty. These are the spec packages that'll determine what your truck will be like to drive. If you're driving a truck and it's not what you expected, talk to the boss. Perhaps he set the truck up for fuel economy, and the one thing they forgot to do was to tell the bloke who drives it all about those hidden secrets.
Electronics are a part of life with Cummins Command engines. If something goes wrong, the engine computer will help you quickly find out the problem On the dash is the electronic readout, simplified into a band of switches and 3 lights. You can actually communicate with the computer through the use of these lights. Ross Mersell is Cummins' senior training technician, and no one has a better understanding of electronics. He explains the use of diagnostics with the Select computer.
All Select engines have lights and switches. The locations of these will vary model to model, truck to truck. Refer to your operator's manual for correct operating procedures or phone your local Cummins service dealer. Okay, you're driving along and a yellow warning lamp comes on. This means that the Select electronics has picked up a fault. This doesn't mean that it's serious, but it should be seen to at your earliest convenience. If a red light comes on, this is a mission disabling failure. This means that you must get the truck off the road as quickly as possible and as safely as possible and contact your local Cummins dealer. Do not attempt to keep driving the truck. Yellow or red, something is wrong. It's time to find out what the computer has to say. It will give us a number or numbers that we can phone through to a Cummins serviceman who will decode it for us.
As the yellow light comes on, Ross takes us through the procedure of extracting fault codes. Shut the engine down and turn the ignition switch back on without starting the engine. Turn the diagnostic switch up. Now count the flashes of the red lamp.
1, 2, pause. 1, pause. 1, 2, 3, pause. End of number. Okay, we just counted out 213 fault code, so I'll just jot this down so we can tell the serviceman. There might be more than one fault code in the engine. So to find out, we flick the idle speed switch to plus and we count out the fault codes. If it's the same, then it means there's only one fault code. If it's different, then it means there's more than one.
The third light, often marked engine derate, will indicate that the computer has begun derating engine power. When lit, the computer will give you between 50 and 75% of power to drive in. It won't shut you down. So the responsibility is with the driver. Use the reduced power to get to a safe place as quickly as possible. If the derate lamp begins to flash, the problem is getting worse. So pull over safely and shut the engine down now. It's important that the interstate driver talks to the serviceman, because the driver's experience can help the serviceman sort out the problem by explaining road conditions and driving symptoms. The computer is a tool to be used, not something to be feared. A tool to help us get going again quickly and safely. Driving a special duty application truck, such as a multi-trailer outfit with a high gross mass, means driving for performance. We've seen the command engines have a horsepower peak lower in the RPM range than what we've been used to. To obtain maximum performance, we have to seek out the area of the driving range with the most horsepower.
If you're a B double driver, the odds are you'll be driving a Cummins Command 460E engine, coupled to a 18-speed or 20-speed transmission. The horsepower peak with this engine is at 1700 RPM.
By driving this truck conventionally to 2100 RPM, you have only 350 horsepower at your disposal. Drive between 1500 and 1900. This gives you a very responsive and powerful driving range. When out on the road, change down when the revs come back to 1550 RPM. And there's little point in letting the revs run over 1900 RPM as you're actually losing power. In a B double in undulating country, you can actually let the truck come back to 1100 RPM when cresting a hill. For the best economy, use the 1500 to 1900 RPM range only when high performance is needed. Remember, there is a cost to performance driving. The truck will use more fuel.
This truck has a Cummins progressive shift. Let's go for a drive and see what happens.
Progressive shifting is a good habit to get into, even with high mass trucks. There is a computerized progressive shift programmed into many command engines. The parameters of the shift are programmed in at the owner's request. The progressive shifting principle is simple. Change gears as soon as there is enough road speed for the next gear to keep acceleration progressing. Manual progressive shifting is a professional driving skill that all drivers should have. The Cummins progressive shift is a ramp system. Each gear, as you work up through the range, will allow you more RPM until the programmed road speed is achieved when you have the full engine RPM range. When changing through the gears, get to know where the progressive shift will cut off power and shift before power is reduced. It takes a little getting used to, but is a fast, fuel-efficient, neat method of driving. Many drivers who are not aware of the function of progressive shift get into trouble in intersections, not through lack of skill, but they rely on the instinct of years' experience. With progressive shift, select a higher gear than previously used. If you leave a truck in a gear and your foot down, you will run out of power.
All select engines will be fitted with a cruise control. This makes it easier on the driver and also helps out with fuel economy. It's easy to use. You just drive up to your desired speed, press the set button, take foot off the throttle, and it just takes off. Piece of cake to use. The computer feeds just enough fuel to meet the requirement of the engine. Now we're going down a hill now, and the computer's cut all fuel to the engine. We're just coasting. As we get to the bottom, you can feel the computer feed fuel to the engine and we pull away. I don't have to do a thing. To disengage cruise control, you just have to touch the brake or touch the clutch or press the set button. Immediately we're back into manual mode. We've just gone through a small town and we want to resume our road speed. You just hit resume, the truck automatically accelerates, and here we are sitting on 100 k's. Automatic acceleration can be carried out just by hitting the accelerate switch and holding it down. The truck again accelerates. When you reach your desired speed, take your finger off, the truck just stays there in cruise control. The cruise control gives a very even fuel burn. It aids economy and certainly makes driving heaps easier. Another feature of the Command electronic engine is gear down protection. This means as you drive in the second highest gear, possibly direct before you go for overdrive, there's a limit on your road speed, maybe in the mid-90s. This means you must go to top gear to be able to make your top road speed. This feature saves fuel and again takes a little getting used to.
Idling is bad for your company. It costs money and it's bad for the engine, which costs more money. All Cummins engines have automatic shutdown. If the engine idles for more than the programmed time, usually about 5 minutes, it will shut down. This is another computerized tool to help you be more professional in your driving habits. The Cummins C brake is fitted to most Command engines. This brake is extremely efficient for slowing without using conventional brakes. To obtain best efficiency, the engine should, in this case only, be allowed to run out to 2100 RPM to gain maximum retardation horsepower. As a driver, you'll know what gear is right to come down a hill. Around the same gear you use to go up the hill is the old starting point.
We're going down the slide or the toll bar in Queensland, which is as steep as any hill you want to get. And we're trying out the Cummins C brake. The C brake at present, on a pretty steep grade, is holding me back around 1600 revs. Now that's fine, but to get maximum retardation, you can let the truck run out to about 2000, 2100 revs. Yes, it's running out a bit higher. Speed's coming up. Just got a grainy here to pass. We're sitting at 2000 revs. Retardation is good here. We're going down safely and at a reasonable speed. I haven't had to touch the brakes since the top.
Your Cummins Command engine has been designed to give performance and economy. This has been an introduction to what to expect when you get behind the wheel. The feeling of power could be different to what you're used to, but the power is there, an economy that will allow you, your company, and your boss to stay in business. Remember these points. The horsepower peak is back in the rev range at 1600 or 1700 RPM, depending on the engine model. The computer controls fuel, so power will feel different. The computer is only a tool that will help you do your job easier and better. For best balanced performance with economy, drive between the horsepower peak and the torque peak, 1200 RPM to 16 or 1700 RPM. Learn progressive shifting. It'll make your job easier. You are driving state-of-the-art machinery that is environmentally responsible. The Cummins Command engine will take you a long way. Drive safely and drive with pride.